Greetings. We are going to look at the law of cosines. Now, I've seen the law of cosines presented in a textbook as three different formulas, but I'd like to help you understand where those three formulas come from so that you only have to have an understanding of one formula and how the pieces go together. We are going to use a diagram where the angles of the triangle are labeled with capital letters, and then the side lengths are labeled with lowercase letters. Now this gives us a repetition of A and A, B and B, C and C with this diagram, but we have capital and lowercase, and each one designates an angle measure or a side measure, and they work interconnectively. The first formula that I have up here is c squared equals a squared plus b squared. This first part you see over here is essentially the Pythagorean theorem. But over here we are subtracting 2 times AB times the cosine of angle C. So we have this adjustment factor. The triangle here does not have to be a right triangle. Pythagorean theorem works for right triangles, and this works for any triangle in the plane. So this is somewhat of an alternative for the Pythagorean theorem. If angle C here is 90 degrees, then this actually reduces to the Pythagorean theorem, and it tells you something about the side measures themselves, because the angle has eliminated this subtraction piece. When we're looking at the givens, we have to have certain patterns, and these are patterns that hopefully you have learned in a geometry class. We want to have things like angle, angle, side, 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 angle, side, angle, side, angle. What we cannot have, we can't have side, side, angle. This does not work. We should have learned that all of these give us congruences between triangles when we have this pattern, and that this one fails to give us a congruence. If you try to use this pattern, you potentially could get two different answers for the same triangle, and that's why this isn't going to work, is because it doesn't guarantee congruence with what you're working with. So we can't have a side-side angle, but we can have angle, angle, side, 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 angle, side, or angle, side, angle patterns in our givens. So what do we mean by this? So let's look at side, angle, side as an example. So let's say that I know that this side, side B here, is 15 units. And I know that angle C up here is 35 degrees, and that side over here, side A, is going to be 31 units. So I have side, angle, side as my givens. Now, if I'm asked to find angle A, angle B, or side C, can we answer those questions? We have this law of cosines over here. Notice that side C is missing, and this is almost explicitly solved for C here. So let's go ahead and use this the way it is presented here and solve for the missing side C. Let's plug in our givens. C is unknown, it will remain unknown. A is 31, so we want 31 squared here. To that, we're going to add 15 squared. We're going to subtract 2 times 31 times 15 times the cosine of 35 degrees. There are a couple simplifications that you can do right off. You can put your squares in here, and you can multiply this coefficient for the cosine. You could potentially just plug all of that into your calculator. One caution that I have seen with students that I want to caution you about is some students will forget order of operations with this formula. They want to try to subtract some things, possibly this coefficient here from these two squares, and then multiply by the cosine of 35. We can't do that. We have to do all of this multiplied together, subtracted from the sum of these squares. So the order of operations is really important. We don't want to lose sight of that when we try to solve for this. So let's look at doing some of the first stages of simplification of this. So I have squared 31, I have squared 15, and I've multiplied to 31 and 15 here. So this is where I was saying that students want to forget about order of operations. They see we have addition here and a subtraction here, and they just want to put these three numbers together, and then they want to deal with the cosine. Well, this 930 has to be multiplied by the cosine of 35, and that term will be subtracted from this sum. We just can't avoid that. So add these two together, multiply these two terms, and then those terms are going to be subtracted. All right, so we have 1185 minus 761.8114 approximately is going to equal c squared. So now that we have these added together, these multiplied, now we can actually do the subtraction. So we have that c squared is approximately equal to 425.1886. I'm just rounding this off to 4 decimal places here. Now we're not quite done. Notice that this is squared, so to get the c value that we're looking for, this length here, we need to take the square root of this term. So taking the square root of both sides leaves us that c is approximately equal to 20.5958. All right, so we get that the value here should be approximately, say, 20.6. Does that seem reasonable with the sides that we already have? Hopefully it does. From here we can solve for these other angles if we choose to. Now that we know all the sides here in this angle, I want to revisit this formula and solve for B, the angle B here. Now angle B is not in this formula. I want to look at that pattern that I talked about earlier. In some textbooks you may see there's 3 different equations given for the law of cosines. But I don't want you to have to memorize 3 different equations. I want you to have an understanding of one equation and how it works for looking at the entire triangle. So let's look at what pattern that we have here. Notice that the side that we have over here on the left-hand side of the equal sign is the same as the angle that we take the cosine of. That's an important observation. Remember, we said that over here, past the subtraction, this was the Pythagorean theorem. So these are the 3 sides of the triangle here. And then the third observation to make is that the 2 sides that we're adding the squares of here is also the 2 sides that are being multiplied together there. With those observations, we can rewrite this so that we can solve for the B angle here. So we're going to kind of work backwards from this. We need the angle B, so we know we need the cosine of B here. So cosine of B. If we have the angle B here on the other side of the equal sign, this is going to be lowercase b squared. This is that side. This has to be, the first 3 terms have to be the sides of the triangle. So since B is here, that means A and C have to be on the right-hand side. a squared plus c squared. So if we have a and c squared here, then we're going to subtract 2 times a times c. And here is the second version of the law of cosines that you might see in a textbook. Now we can do the same thing for angle A as well. This can be a squared equals b squared plus c squared minus 2bc cosine of a. And there's our 3 forms. We're just looking at the 3 observations to build the equation that we need for the thing that we want to solve for. So again, we're looking at the angle here is paired with the side on the left-hand side. The other 2 sides of the triangle have to be immediately to the right of the equal sign, and then whatever sides that we are adding the squares of have to be multiplied by 2 over here with the cosine. And you can build those 3. Right now, I said I wanted to solve for angle B, so we're going to use this second version. All right, now we want to fill in our knowns. B is 15, so we want 15 squared here. A is 31 squared. And then C is 20.6 squared minus 2 times 31 times 20.6. And that's all times the cosine of B. Now, this is going to have to remain B because it's an unknown. Depending on how good you are, how quick you are with your algebra, you could have just solved this for the cosine of B or solve it for B itself. We're just going to run through the simplification again on this and solve for B. All right, I've got it simplified down to where we were before with the subtraction here. Before we had our unknown over here, now we have our unknown here. We need to do a little bit of algebra. We need to get B by itself. So the first thing I'm going to do is I'm going to subtract this sum from both sides. I'm subtracting 1,385 and 36 hundredths. From both sides, and that's going to leave that term by itself. All right, we have a negative over here, we have a negative over here. That's a good thing. When we divide by this term, we'll have negative divided by negative, giving us back a positive, and that's a good thing. So now we're going to divide by All right, so I have 0.90852 is approximately equal to cosine of B. How do we get B by itself? Well, that's a trigonometry thing. We have to know what the inverse function is for cosine. So over to the side, just to talk about this, if I have cosine of B and I want B by itself, I need the inverse function of cosine, which is the arc cosine. And then these cancel, giving us the B there. So we're going to take the arc cosine of both sides. That gives us approximately 24.7 degrees over here. And we can use the other version of the law of cosines if we want to find A. We could also use the triangle angle sum theorem from geometry to find this, because we know there's 180 degrees in a planar triangle. So we can subtract these two from 180 degrees to get this last angle. One nice thing about mathematics is when you know multiple techniques to determine solutions, you can use both those techniques to check yourself to find your own errors. Using the triangle angle sum theorem, we can take 180 degrees, subtract these two angles, and get that this last angle A should be 120.3 degrees. Now, going back through and using the third form of the law of cosines, we can substitute in the information that we have, with A being the missing value, work through the simplification steps, and see that we get that this is approximately 120.283 degrees, which you can certainly round to get this answer. So using the law of cosines or the triangle angle sum theorem gives us the same results. This lets us know that the work that we are doing is correct. We are able to check ourselves. We don't need the back of the book. We don't need a friend. We don't need to ask the teacher or professor or whatever instructor that you have. You can check yourself. This is one of the nice things about mathematics, is the independence that you can gain from understanding the interconnections. Hopefully this has been useful to you. I'll throw one last problem up here and then do the solution so that you can check your own understanding. On this setup, you have that side B is 10, side C is 18, angle A is 28, and you are being asked to find side A. All right, the form that we have here is not quite the best form because we have angle A here is a given. So I want to have something that has angle A in it. So cosine of A is going here. A squared is going on the left-hand side of the equal sign. We'll have C squared and B squared on the immediate right. And so we'll have 2 times CB here. So this is the form that we need, and now we're going to plug in our information. All right, so plugging in the information, we have this here, and now we run through the simplification. So I get that A should be about 10 1/3 units here as we run through the simplification here. Hopefully that is the solution that you got. Cheerful calculations.